let's look at another related rate problem. Suppose that the price of a certain brand of eggs, and the price is given in dollars, so our price P is given in dollars, is related to the weekly supply in thousands by the following equation. So 625 P squared minus X squared equals 100. If 20,000 cartons of eggs are available at the beginning of a certain week, and the price is falling at a rate of 8 cents per carton per week, at what rate is the supply changing? So before we start, we notice that we're talking about a rate of change given as price over time and also supply over time. So our functions P and X are actually, we're going to think about them as functions of time. So our related rate is time. So what are we given? So let's find out, first of all, what we're asked to find. That's the first thing we want to do. What are we asked to find? What rate? It says, at what rate is the supply changing? So we want to find out the change in supply, which is X, the change in quantity with respect to time. So we're finding dx dt. Okay, we're given a change in price. So let's write out what we're given, what rates we're given here. We're given change in price, so dp dt, and it says it's falling at a rate of 8 cents per carton. Now, since P is given in terms of dollars, then 8 cents in terms of dollars would be 0.08. And it's falling, since it's falling, we're going to call this a negative rate of change. So the price is going down by negative 0.08. All right. So the first thing I'm going to do is find out what rate that we're asked to find and what rate that we're actually given. The second thing we're going to do is we're going to take the derivative of both sides of this equation with respect to that common independent variable t. So I'm going to take the derivative with respect to time on both sides of this equation. All right, then we're going to simplify here. Here we're going to use remember we're thinking about P and X as those dependent variables, functions of time. So here we're going to use the chain rule. So I'm going to do 2 times 625, that gives 1250. Write down the inside function as is, and then multiply that by the derivative of that inside function. Since we don't know exactly what P is, then we're going to call that dp dt. Minus, now we're going to take the derivative of the next term, also using the chain rule. So we're going to bring out the 2, multiply it times the front, write down the inside function as is, reduce the power by 1, and then we're going to multiply by the derivative of the inside function. Since we don't know what x is exactly, we're going to call it dx dt. Equals, and then once again on the right hand side, we have a constant, and the derivative of a constant would be 0. Okay, so we take the derivative of both sides with respect to time. Put that in red. Okay, so the next thing I want to do is fill in any of the known quantities. So we're going to plug in any known quantities. Okay, so let's see what we know. Okay, so we have 1250 times P. Okay, do we know P? Not exactly yet, so I'm going to hold off on that. Do we know dP dt? And we do. I'll leave a space for P there. dP dt is negative 0.08 minus 2 times x. Let's see, do we know x? We're actually told that x we're actually told that the carton of eggs is 20,000. And let's go back to something here. Our supply is given in terms of thousands of cartons. So when we plug in this value of 20,000, we really want to think about this as x equals 20,000. So we're going to use the number 20 in place of x. Okay, dx dt, now that's what we don't know. So I'm going to write dx dt as that one thing that we don't know, so that one unknown quantity. So we might be thinking, okay, well, what about P? We need to know what P is, otherwise we won't be able to solve the equation for dx dt. Well, here we're given a little hint here. It says to find the value of P, we're going to solve for the value of P using our demand supply equation, our price supply equation here. We are going to use x equals 20, and then we're going to solve for that value. So I'm going to come right here and I'm going to solve for P. Alright, so we're going to solve the supply equation here for P. So I'm going to put 625P squared minus 20 squared is equal to 100. Okay, 20 squared is 400, so I'm going to add 400 to both sides of this equation. So I get 625P squared is equal to 500. Divide both sides by 625. Okay, when I do that, I get 0.8. And then we're going to take the square root of both sides because we want to solve just for P. Okay, we're talking about a price here. So we're not going to put plus or minus, we're going to keep it positive. And we're going to write this as P is equal to the square root of negative 0.8. Now we want to substitute that quantity right back into our equation in place of P. Alright, so now I'm going to solve for dx dt. I don't want to round anything until the very end, so that's why I'm not putting my calculator to square root of 0.8. If you do, you're going to get a long string of numbers after the decimal. I'm going to leave it as square root of 0.8, and that way I don't have any rounding errors at the end. Let's simplify a little bit before we solve. So I'm going to leave the square root of 0.8 as the square root of 0.8 because that is something that would give me an approximation that I would have to round. I'm going to multiply 1250 times negative 0.08. And I get negative 100. So negative 100 times the square root of 0.8 minus 40. We'll go ahead and simplify there, dx dt. So we have these two different terms here. And I want to solve for dx dt, so I'm going to go ahead and bring over any term to the other side that does not have dx dt. So I'm going to write this as negative 40 dx dt. I'm going to bring this to the other side, so I'm going to add that to both sides of the equation. Right, then I'm going to divide both sides by negative 40. Okay, so we get that dx dt is equal to, and then I want to throw that into my calculator here. Alright, and that's what my calculator gives me. So it's a negative value. We're asked to round once again to the nearest whole number. So I'm going to first multiply by 1,000. And then since my decimal place is now here, we're going to use this to decide if we want to round up or stay the same. So we're going to stay the same. So our rate of change of supply is negative 2,236 units per week.